Senior 3. I hope you're well. I hope you're enjoying the COVID holiday. Welcome to this COVID session where we are going to be engaging ourselves. Standing before you, I am Madame Sophia Nassali. That is my name. So during this period, I'll be taking you through mathematics, your best subjects, I know some of you, and the physics. Okay, so without wasting time, because we are operating on data, in fact, it's without wasting time and data, we are going to go through the package that you have, which is titled Teachers of Substance, Year 3 package. I basically want us to go through those numbers. I know you must have tried out some, and I'll be looking through your work as you'll be uploading it. But in the meantime, still let us go through it as you're checking through your work, check through what you did, check the mistakes, and then correct them. Okay, so number one. Number one was factorizing 2x power 4 minus 32. So there are these two words which normally students confuse out: factorizing and the expansion. Expansion is like making something appear big. You expand it, you open it. But then factorizing is like the opposite. With factorizing, it's all about you package it so that it appears small. Okay. So when it comes to factorizing, it's all about how do we package a given equation or a given number so that it appears small. It's all about identifying the common factor, if at all there is. So it's all about identifying the common factor, if at all there is, and then work on those common factors. So when you look at the expression that we have, 2x power 4 minus 32, they are basically two terms. This is the first term, 2x power 4, and then 32. Look at those two terms. Is there any common factor? Yeah. The common factor, in fact, here is 2. What do we mean by the common factor? Is there a number that is divisible by both terms? Or is there a number that is shared by both terms? Take an example. If there was x here, we would have said the common factor is x, one of the common factor. But here we are saying that the common factor is 2 because 2 is divisible by both. So what are we going to do? What we are going to do first, we shall factorize out the common factor. And which common factor we have said is 2. So when we factorize out 2, it's like we have removed the 2 from here. How have we removed the 2 from here? We've divided 2 here. So what have we remained with? X power 4 minus, the sign doesn't change of course, 32 divided by 2. This would give us, 16. So this would give us 16. Okay, so this is what we have. Having factorized out 2, what we remain with inside the bracket is x power 4 minus 16. And when you look at this question, it is normally a question in section A, which carries 4 marks. So I don't think there is anyone who says we can now stop here. You can't earn 4 marks by just having this one step. So how can we go further to factorize definitely this bracket? So when you look at this bracket, looking at x power 4 and 16, they definitely have nothing in common. They have no common factor. Because here the only term we have is x, the only term we have here is 16. There is no common factor. So here we cannot talk about what is the common factor, no. But here, these two terms are separated by minus. That means we are having a difference of two terms. So as we start to talk about difference of two terms, that should make you remember what we call a difference of two squares. A difference of two squares, as you can hear the word, is simply an expression having two squares separated by a minus. For example, if I have x squared minus y squared, this is a difference of two squares. If I have p squared minus 2 squared. This is a difference of 2 squares. So, a difference of 2 squares can be factorized. And how do we factorize a difference of 2 squares? What are the 2 factors which, when multiplied up, give us a difference of 2 squares? So if we have a difference of 2 squares like x squared minus y squared, the 2 brackets which can be multiplied up to give us this x squared minus y squared are x plus y, then the other one is x minus y. In other words, these 2 brackets, when multiplied up, they will definitely have to give you this difference of 2 squares. We are just limited by time, but you can also work it out. You remember, you know how to multiply 2 brackets. First number multiplies the second bracket and so on. But once you do it well, you'll be able to get this. So the same applies. If it is p squared minus q squared, this one will be p plus q into p minus q. The other one is, take an example, if it was m squared minus n squared, it would have been m plus n into m minus n. You can definitely have many differences of 2 squares and you can try to factorize them out. So, does this look like a difference of 2 squares? Quite not so well, but what we are sure of is that it is a difference. It is a difference. A difference of 2 squares. That means we must have a square here, we must also have a square here. That means we must have a number squared. And we know that 16 is a perfect square because it has a known square root. What is the square root of 16? I know we know it, okay? So take an example. If we have a term like let's say x squared minus 4. The question is this a difference of 2 squares? That's the question. Is it a difference of 2 squares? We would say yes and no. Yes, it is a difference of 2 squares. The first one is a square, but the second one is not a square. But we can make it a what? A square. By writing it as x squared minus 2 squared. Because we know 2 squared gives us a what? A 4. So this is now a difference of 2 squares. X squared minus 2 squared. Which we can expand. Which can be factorized as, let us follow this. So this is like our first term, and this is the second term. This will therefore give us x plus 2 into x minus 2. So you realize that difference of 2 squares is not only with letters, but we can also have numbers. We can have a number which originally is not a square, but we can transform it into a square. So back here, I had said that this is a difference, and we can also make it a square. Say that we make it a difference of 2 squares. So what are we going to do? X power 4 is not a square. It is not a square. 16 is not yet a square, but we've seen that just like 4, 16 can also be written as a square. X power 4 can also be written as a square. How? X power 4. What do we mean by a square? We need a power 2 somewhere. So x power 4 is just the same as x squared again squared. How does this transform into x power 4? I want us to remember the laws of indices. If 2 powers meet up, they multiply up. Just like, for example, if I have x cubed, then again I square, this one becomes x power 6. So it implies that x power 4 can be written as x squared, then again squared. This one definitely gives us x power 4. But what we want is a square, to create a square. So what we are going to do is to write, this is our 2, we are going to write x squared, then squared, minus, create a square here. What is the square of 16? Which number do we multiply twice and we get 16? That is 4 square brackets. Okay, so this is now a difference of 2 squares. It is in the form of a squared minus b squared. Our a being x squared and our b being 4. Both of them have the square. These are the squares that we're talking about. So let us now factorize this. This will be 2 into a plus b into a minus b. Our a is x squared plus the b, which is 4, into brackets, x squared minus the b, which is 4. Yes, we have factorized somehow. We have factorized. Okay, so this is x squared plus b, but remember we said our b should be a what? A 4. So we have factorized. But the question was saying probably factorize, and we need to factorize completely. Completely means until when we cannot factorize any further. So 2, we can't do anything about 2. This bracket is okay, but then this one, it is also again another difference of 2 squares. So let us again factorize this. So this becomes 2 into x squared plus 4 into, this is again another difference of 2 squares on its own, which is x squared minus 2 squared, creating a square here, which will give us a plus b. I want us to remember this, to give us a plus b into a minus b, which the a that we have now is the x, and the b that we have now is the 2. Okay? So let us factorize it as a difference of 2 squares. This will give us, don't forget that this is a 2 squared, this is x squared. So this will give us x, that is a plus b. X plus the b is 2 into brackets, x minus 2. So this is now completely factorizing this. I know it has not been so easy, but it has been just rotating about understanding difference of 2 squares. And such numbers are kind of tricky, so you need to do more practice when it comes to difference of 2 squares. It doesn't only stop at this. We also have to look at those numbers where there are some other gymnastics that we need to add in so as to overcome that number. So this is our final answer. We shall have factorized it completely. So that was number 1. That was number 1. I hope you've got it. Okay, you will, as you internalize it. Let us go to number 2 now. Number 2. Number 2. So I'm not going to write the whole question here to save time and space, but I believe you have the question, so I'll just summarize the question here. Number 2, on a map, the distance between the 2 points is 16 centimeters. That is distance on the map is 16 centimeters. Calculate the scale of the map. The actual one has to calculate the scale of the map. If the actual distance between the 2 points is 8 kilometers, the actual distance, now we know that a map is a representation of what is happening on the ground. So when it comes to the scale of the map, it normally compares the distance on the map and the distance on the ground. So when the map of a certain area, let's say, is drawn, the distance between the 2 certain points on the ground is 8 kilometers. But after drawing the map, the distance comes out as 16 centimeters. So that's why we call this distance on the map. Then the 8 kilometers that have been given is the distance on the ground. So here we actually have distance on the ground. Distance on the ground, which is 80 kilometers. So I normally tell students that first concentrate on the question. First concentrate on what the question wants. Here the question wants us to get the scale of the map. What do we mean by the scale of the map? The scale of the map basically gives us a relationship between the distance on the map and the distance on the ground. I'll just give you samples of scales of the map. For example, you can find a map on which the scale has been written as 1 to 20,000, another may be 1 to, let's say, 50,000, or 1 to 20. So what does this value mean? This value is normally comparing the distance on the map and the distance on the ground. And then you never find units on our scale. But though it has no units, both of these two distances are in centimeters. Okay? Another way of expressing the scale on the map is in terms of what we call the representative fraction. Here I will write 1 over 20,000. Here I will write 1 over 50,000 and so on. So it can either be written in ratio form or in fraction form. So basically, that is it about scales. So they want us to calculate the scale of this map. First, take this off. They want us to calculate the scale of this map. Okay, so how shall we come up with the scale of the map? As you have seen my sample scale that I gave you here, when we are writing the scale on the map in ratio form, the first number should always be 1. 1, then the other value. What does 1 to 20,000 mean? This is map, this is ground. It actually implies that 1 centimeter on the map represents 20,000 centimeters on the ground. So if the question is asking you to calculate the scale, in other words, the question is asking you to calculate what 1 centimeter on the map represents in terms of centimeters on the ground. So our scale would say it should have no units. But though it shouldn't have no units, as you're writing the final value, it should have no units, but it is actually comparing two distances. And you cannot compare two distances if they are in different units. So it implies though it has no units, but the two distances are actually in the same unit, and that unit should be centimeter. It actually has no unit because since it is ratio, the two units cancel out. But which units cancel out? Centimeter and the centimeter. Okay, so if we have distance on the map, we have the scale, we are looking for the scale, we have distance on the ground. How do we look for our scale? There are like two ways of arranging the working. I will not call them two methods, they are just two ways. So the first way, we can arrange our work in form of kind of ratio map here, ground. Okay, so what do we have? Distance on the map, 16 centimeters. And then distance on the ground. Yes, we've been given the distance on the ground is 8 kilometers. But why am I hesitating to put it here? Because these two units must be the same. And which unit do we need to put here? Centimeter. Because remember, I told you that finally, our scale, though it will have no units, simply because the two units cancelled out, and which two units cancelled out? Centimeter, centimeter. So whenever you're working out scale, first convert the distance you've been given on the ground, which is normally in kilometers, first convert it to centimeter. So what we are going to do here is to convert 8 kilometers to centimeters. Convert. And if we are to do any conversion, we must have a conversion unit that we are to use. So we know that 1 kilometer, we know a kilometer is bigger than a centimeter. 1 kilometer is actually 100,000 centimeters. You can check this with King Herod, or you can just go step by step, change 1 kilometer to meters. 1 kilometer is actually 1,000 meters. And yet 1 meter is 100 centimeters. So that's how we come up with the 100,000 centimeters. But you can just get this stick in your head. Therefore, if 1 kilometer is 100,000 centimeters, let's convert 8 kilometers to centimeters. What about 8? What about 8 kilometers? So definitely just be a matter of multiplying. This will be centimeters. So you come and put it here. The two values must have the same units. So I'm now removing that space, and then we are putting 8 times 100,000. This is now centimeter. Okay. What does the scale mean? The scale means what does 1 centimeter represent? What does 1 centimeter on the map represent? So remember the sample scales that I gave you, they all had 1, 2. 1, 2. So what do we have to do? And we say this one is 4 on the map. So what do we have to do? Create 1 here. How do we create 1? Definitely dividing through with 16. Okay? Divide through with 16. So you divide through with 16, we shall remain with 1 centimeter on the map. Represents it. When we multiply 8 times 100,000 over 16, we are getting. Okay, that is 8. I hope you're also doing the mathematics. Times 100,000 equal divide by 16, giving us 50,000. So this is 50,000 centimeters. This is marked, this is brown. So how do we set the scale? There are 4. The scale is 1 to 50. No units. Why? Centimeters. And this is a ratio. You can divide through with centimeters. They cancel out. But I just left them on to emphasize the issue that the two must be having the same units. So that is how we get the scale. If we are given distances, and if you are given distances, that is quite simpler compared to when you're given areas. So I encourage you to look for another number which also requires working out the scale, but when this time round you're given areas. Okay, that one for area is a bit challenging, but not so much, only that you just have to be knowing how do I make the conversion of 1 centimeter squared, let's say, into kilometer squared. Remember how we used to do it in senior 1. So that is number 2. This is number 2. So let's go. Let's move on to number 3. Let's move on to number 3. Yeah, I'm smiling because I'm seeing logarithm. And I know some of you, when you hear the word logarithm, you feel like burying your head in the sand. But you don't have to run away from challenges. You just have to face them squared. Okay, let me clean this board for logarithm. The whole of it should be clean, in fact, as we are going to this number of logarithm. Because with logarithm, you just have to be very keen. Your keenness matters a lot when it comes to logarithm. So, how do we use logarithm to evaluate? The question is, use logarithms to evaluate the square root of 61.51 times 4.93. Square root is over 31.33. Use logarithm. Definitely here, if you have to use logarithm, I expect you to be having a logarithm tables. Yeah, logarithm tables. But if you fail to get a logarithm table, at least get a scientific calculator, and then ensure that it must have that button for log, and then beneath it must have anti-log. So make sure that the calculator has that. Okay. So how do we use logarithms to evaluate this number? Square root of that number. Okay. Take an example if we are to use logarithm to simply evaluate such a number. Without the square root. Okay, I want us to look at the difference between these two numbers. In both of these two numbers, we are multiplying up and down we are dividing down. But this one has no square root, whereas this one has a square root. So how is this different from this one? The only difference is that this one has a square root. So if it has a square root, as we are working it out, how are those two workings different? So we know that if we are to attempt this number, if we are to work out this number using logarithms, we definitely have to organize our working in form of a table. Okay, and in that table we normally have the number, then here the standard form of the number, and here the log. So the first number here would be 32.1, writing it in standard form. What do we mean by standard form? This is taking us way back in Form 1. In standard form, we must ensure that the decimal point is between the first two non-zero numbers. First two non-zero numbers. So what are we going to do here? Shift it here. Find that it is 3.21. But then times 10 to the power is the number of steps that the decimal point has moved. But since it has moved towards the side, it is positive 1. Then next, this is the first number. 32.1, write it in standard form. Then next, the logarithm. Why are we writing it in standard form? Because when you look at our logarithm tables, the numbers whose logarithms can be worked out are definitely always the standard, this first part. A number like 32.1, you may find that you may not find the logarithm of this number using the logarithm table. So that's why we simplify it and write it in standard form. So having written it in standard form, the logarithm of this part can be got from the log table, but the logarithm of this part is 1. So the logarithm that we need here is the power 1 here plus the logarithm of this. Good. Next, 2.91. 2.91, write it in standard form, do the same. Then the other number also. Okay, so this is just drawing your attention onto what we are supposed to do. How are we supposed to work it out?